All right, well, we'll go ahead and get started. So welcome to our pre-recorded webinar, Why Presenting the Average Alone is Not Particularly Useful, Measures of Variance, Data Spread, and Offering Broader Context for Editorial Office Performance Metrics. This is the fourth in a series of webinars sponsored by Origin Reports. And Dr. Jason Roberts is our speaker today. Following his recorded talk, we'll have a live question answer session with Sherry Hill, who is the Origin Reports project manager. My name is Erin Landis. I am the managing director for Origin Editorial, and I'm today's moderator. So just a little bit about our speaker, Jason Roberts, before we get started. Jason is a senior partner at Origin Editorial and Origin Reports. He is the founding president of the International Society of Managing and Technical Editors. And in 2017, he published the book Peer Review, Reform and Renewal in Scientific Publishing. Additionally, he is an editorial board member of the journal Research, Integrity, and Peer Review, and has worked with the Equator Network on elevating reporting standards. Jason is considered an expert on editorial office reporting and has spoken at numerous industry conferences on this topic. So I will now ask our behind the scenes team to start Jason's presentation.
Hello, everybody. My name is Jason Roberts of Origin Editorial, and I'm pleased to give a presentation today on for the Origin Reports webinar series on measures of variance and data spread. And what we're going to look at today is providing greater context for the data that you present in your editorial office reports. And this in turn may help you shape policies and protocols for how you run your editorial office. So I'm just going to launch with an example. We're going to talk again, like I said, about missing contextual data. And I think this example here perfectly illustrates the point. What do we have? I'm reporting the time to initial decision for 2019, 2020, and 2021. We know across all 3 years that the mean turnaround time was 41 days. And we are reporting that on these types of articles, and this number of decisions were made. So every year there was 100 decisions. Quite coincidentally, there was 100 decisions made each year on those article types. By the way, as I've mentioned in previous webinars, and one of the things that the Origin Reports reporting tool offers is that you can collect this information and present that so that people know precisely what you were reporting on. That's a side note. Let's get back to the main issue here. So, okay, each one of these years took a turnaround time of 41 days. But there is a difference between each of the 3 years. And that is that the standard deviation goes down from 18 days, 16 days to 14 days. And the interquartile range even drops from 12 days, 11 days to 10 days. And if you're thinking, what are those things? That's what this presentation's about. And we're going to talk about them and explore them in depth. But the reason why I present this information is that they are both telling a story. And what is the story? And the story is this. So we know that it took 18 days, standard deviation, around, so that's plus or minus 18 days around that mean of 41 days. And again, I'll talk about the calculation in a little bit. By 2021, it was down to 14 days. I know in 2021, therefore, the journal was more consistent in providing a decision within 41 days mean. So basically, we didn't have as many outliers. So though we were 41 days there, though we're 41 days there, there are more outliers here. That means that some authors had a very quick experience, maybe, but a lot of them, or several of them rather, I should say, had a very long experience. Maybe it took 80, 90, 100 days to get it done. I think consistency is every bit as important as being expeditious. Let's be honest. The individual author experience is paramount here. And what we want authors to have is that perfect experience. Well, they're not always going to get it, but we need to make sure that we are aware of how, when we go to measure data, we don't just pat ourselves on the back and say, yes, great, we were 41 days again. If in fact your standard deviation is going in the opposite direction to what happened here, if your standard deviation is getting bigger from where you were before on the same mean, then that suggests you're not being as consistent, which means authors may get a highly variable service experience from you. So consistency is key here. What we're looking at is a way to detect whether you are consistent or not over time. There's a lot of words there. I hope I didn't lose you. But basically, what I'm trying to say is, let's find a way to see how well you're doing year on year beyond just presenting the mean. Okay, so are you reporting what you think are all the key values in your performance reports? If you're not reporting a standard deviation or a interquartile range, then you aren't providing all the information that you could provide, both to yourself and certainly to your editors as well. Now, most of us that work in editorial offices probably don't have statistical backgrounds, but a lot of our editors maybe do have statistical training, so they actually would really appreciate that information, even if it doesn't really mean much to you. I must admit, I don't really truly understand, I can't look at the data and just go, well, standard deviation of 10, standard deviation of 12. It's rather meaningless unless I look at it visually. I do understand the interquartile range a bit more because it does kind of make a bit more sense visually. And so if you're a visual learner like me, you might be able to then convey very clearly whether you're being consistent or not. So you want to make sure that you yourself and your audience can take away a full data-derived understanding of everything that you're measuring, certainly your journal stakeholder performances. So for example, if you're measuring turnaround time of reviewers, how long do they have a manuscript before they post their review? It's really critical that you actually do have information like the standard deviation or the interquartile range to measure the overall reviewer performance, because you can see year on year, just because the mean drops, is that actually just because there was a few really fast people and they pulled your mean down, or did in fact was it due to the fact that you were more consistent? Are you confident that you are basing processing protocols off data points with full context? Again, what do I mean by this? It's all about understanding consistency. Just because your mean dropped doesn't mean that you should pat yourself on the back and go, I think we're doing okay, we don't need to worry. If you've got greater inconsistency in that in those data points, then I would be worried that you might have a bigger problem, because it might have been just fine this year and your mean didn't shift, but maybe the next year your mean might shift, and then you're going backwards, and then people start asking what's happening. Why did we go backwards this year? So we're going to learn a little bit about the spread of data and why that's important that you provide that information on the spread of data. So you're not just reporting one highlight statistic, you're actually given a bit of background to it. So what you need to do is calculate what's called a measure of variance, okay? And without a measure of variance, only half the story is told. So the example would be this: you give the mean, but you don't provide the standard deviation. So I know that you took 41 days, but I don't really know how consistent that you were in that. You might have had some very quick people, you might have had some very slow people. If it's the median, then you would use the interquartile range. And then what would be wonderful, and I know this might be beyond most of us, would be to actually present that as a nice, beautiful chart like this. But these actually tell a story right here, and we'll explore that a little bit more as well. So just even if you're not really understanding the statistics, you could look at this visually and go, maybe something's happening with my journal when the curve looks different from one year to the next. Okay, so what are these measures of variance? It is a summary statistic. It represents the amount of spread or scattering in a data set, most commonly given as either a standard deviation or the interquartile range. So again, that's what I talk about with consistency. If all your reviewers get their reviews, let's say you give them 14 days, and let's say they all get it done between day 12 and day 16, then you're going to have really clustered together data. So your spread is not great. Your data is very close together. So you'd have a small standard deviation in that respect. If your reviewers are all over the place, for example, and that's what you're measuring, reviewer return times, then you've got a large spread of data. Now, I know you're probably looking at this equation at the top here going, what on earth? Don't worry, because you know what? Excel calculates that for you. And so it only takes a second or two to calculate the mean. The interquartile range, Excel can do that too. Now, I'm not going to show you how to do that in these presentations because every version of Excel is different, but there's YouTube videos out there. You can just read it up yourself. It's very, very straightforward. Let that take the strain for you. At Origin Reports, we've started to introduce both of these metrics into a number of the reports that we produce. Okay, so why are measures of variance important? why are standard deviations into quartile ranges important? Well, they enrich our data interpretation to better understand what is happening. So you've told me it's 42 days, but I don't really know, are you being consistent? If you just tell me the mean's 42, I only know so much. I know that you take 42 days on average. That's all I know. But there's more information that you can reveal, and it takes just a few seconds in Excel to calculate these things and then add them to a data table when you present your reports. Measures of variance can help us understand if an experience is uniform. And that's what you should aspire to when running your editorial office. It shouldn't be that some authors, by the luck of the draw, end up getting a wonderful experience and others get a bad experience. You need to be able to monitor that, obviously, but you also need to be able to go back and look at your performance to benchmark your future performance. Okay, so here's an example. We have two journals here, one on the left, one on the right, and there's charts at the bottom. So the mean turnaround time to initial decision is 41 days for both of those journals. One is offering a wildly variable service. So some people are really fast, some people are really slow. And though expeditious peer review is important, so is consistency. And so what I'd be looking at here, if I was the journal that's wildly inconsistent, is how can I become much more consistent? So I'd obviously put in place a bunch of practices to monitor these things. But before you can do all that, you need to have the data behind you to suggest, yes, we have a problem. So just in case you're wondering, the journal on the right is the one with the wildly variable service level. So it's got a lot of people over here that got a very quick turnaround time to initial decision, way more than this journal had. But it's also got some people over here that took an awful long time to receive their initial decision. And so this journal is much more consistent. And you'll see another data plot I'll show you a little bit later, where it is somewhat consistent. You see that things build up to the mean, and then they drop away again. This is probably what you'd want to aspire to, because inevitably some things are going to run late. What you want to make sure is that the really late ones are like this and not like this. Okay, so three things that you could report on when you present your data: the range, the standard deviation, and the interquartile range. So if you report the standard deviation, again, I said this a moment ago, but I'll just repeat it, you would be basing that off of the mean, which is usually called the average, okay? And certainly if you're using Excel. If you are also reporting the interquartile range, you base that off of the median, okay? And all of these things can be calculated in Excel and with most charts in Origin reports. And so this is just an example from my rather old version of Excel, how I would want to report on the interquartile range. Again, I'm not going to show you here, but YouTube videos will tell you what to do. So ranges, let's just quickly look at those. So ranges can reveal the best and worst case scenarios, and that is what they do. So in this table below, we can see the outliers. So we know that the fastest a manuscript receive a decision, and let's forget about distinguishing between immediate decisions and decisions that go through peer review. In this made-up example here, the fastest decision was 7 days. The slowest decision was 130 days. So we report the minimum and maximum, and again, Excel can calculate that for you, and then you report the range. And so if you want to then report that information, it would give your consumers of your report some information as to how well you did at controlling the outliers. Now, yeah, that's great. 7 days is wonderful. The maximum is a concern, because my first question would be, how did something take 130 days? Why did it last that long in peer review? So somebody will probably ask that question. That's up to you to make sure you have the answer. And I'm no doubt there's many reasons why that happened. But there is a problem with ranges in isolation, if that's all you're going to present, and that is that they tell us little about the typical experience. They tell us about the awful or the brilliant experience, but they don't tell us about what happened to the overwhelming majority of people. The data, the spread of the data could be highly variable. This might be scattered all over the place, but we don't know. We know where the outliers are, but we don't know what's happening between them. And it could be that they're clustered tightly together with some outliers over here, or it could be that they're just evenly spread out. We don't know. Okay, so they are a solution, but they're not the solution. So the most common thing that I often see in editorial board reports, if they do report a measure of variance, is the standard deviation. So they'll tell you the mean turnaround time is this, And as you're hearing, we use these things mostly for reporting time. Okay, so time to first decision, time to final decision, time that reviewers have the manuscript, time that authors are spending in revision. All of these things can be measured. There's a mean, but you want to make sure that there's a standard deviation to go along with it. It's a common statistic. It's dead easy to calculate in Excel. And so you don't need to worry about that complex equation I had for you before. But what does it mean? So as a rule of thumb, your mean, your average, plus or minus the standard deviation will tell you where 68% of your data will fall within your data set. Okay? So if that's like, what do all those words mean? Maybe this visual example will help. So what I'm saying is this. Okay, let's say the time that reviewers take to do an individual review of your journal is 20 days. Okay? And the standard deviation is 10 days. Okay? That means, okay, so that's 20 days. Let's pretend that that's 10 days and that's 30 days. So 10 either side of that mean of 20. That means 68% of the reviews that are returned are between 10 days and 30 days, okay? Which and eventually gives us that mean of 20 days. Okay, so that's what's happening there. So you can see now that I'm able to report on at least how just over 2/3 of all the reviews are in. So that's, I'm now starting to give some fairly interesting information as to how well a journal is doing. This means that these reviews will return really quickly. This means that these reviews were returned very slowly. But I know between 10 days and 30 days, 68% of my reviews were received in them. Now, you don't need to generate a bell curve like this. You can if you want, but you can just give the summary statistic. Mean of 20 days, standard deviation, 10 days. And that means 68% were between those periods. So you might report it in your editorial office reports like this. So you could say, I have a mean of, in this case, 41 days, minimum of 7, maximum of 30. My range is 123 days, 130 minus 7. And my standard deviation is 14 days. Okay, so that would mean between 27 and 55 days, around that mean of 41 days. So this allows for a more accurate representation of the spread of data than just the range alone. And this is great for doing year-on-year data reporting. So, just as isolation in and of itself, just 1 year reporting the standard deviation, that's interesting. But it's more interesting if you can report the 5 previous years, and then you can look back and say, okay, well, my standard deviation has dropped tremendously. That means I'm way more consistent. Okay. But there are some issues with standard deviations, okay? So there's my little bell curve again, 68% over there. The standard deviation calculation assumes that your data is normally distributed. And here I go again with a statistical term. What does that mean? Well, that means that you have just as many values that are higher and lower than the mean, so that they're almost like the mirror image of one another, that your data is very evenly dispersed, it mirrors each other, it's a very similar pattern. So it all fits very neatly into this beautiful looking curve. Now, the reality is your data is going to be messy. And, what you will find has happened is that outliers can make a real mess of your data. So you may actually find that you've got a lot of really quick stuff going on over here, but you've got some outliers up here that have pulled your mean in the wrong direction, or at least in a direction that isn't telling you the whole story. Okay, so this is an example of what I mean here, is that really our data is very consistent, but whoa, this turnaround time here of 80 days is going to totally mess with my mean now. Okay, so just to illustrate the point that your data is messy, this is a real example. It is from a journal, and what we plotted here is along the bottom here are days it took for a reviewer to return a review. So 14 days for reviewers to complete a review, which funnily enough is also the most common day, but it's also the day's number of days that they were given to perform a review. This I have plotted for journal after journal after journal, and I've never yet found a journal that doesn't conform to this. If you say 10 days, 14 days, 21 days to get a review done, the most common day that you will receive the review back is those days, 10, 14, 21 days. It's just, this seems to be behavior. So this is not exceptional. But what I'm telling you here is something that's really interesting, that your data is not normally distributed. I haven't got a beautiful bell curve here at all. Okay, so so you understand this clearly, this is the number of reviews returned. So I had 55 reviews that were returned on 14 days. I had maybe only about 7 or 8 reviews that were returned 3 days after the invitation to review was accepted. So we have messy data. And so we now have a potential problem with the standard deviation. With this example here of time for reviewers to return a review, we're unable to say with confidence that a value is just as likely to fall the same distance above or below the mean value. If the mean is skewed by a couple of outliers, the standard deviation will also be skewed. So these problematic things over here are going to pull your mean upwards, and that's going to mess with your bell curve. Okay, so Jason, you've just told us that the standard deviations are something to report. They are. Definitely, I would encourage you to report them. However, I want to talk about another metric, which I see published less often, but I actually think is a far better metric. And indeed, certainly at Origin, we encourage all our editorial offices to report a median along with an interquartile range. Okay, so just take a pause here. So what is this exactly? So if you remember back to your high school statistics, the median, it was that middle value. So it's not calculated in the way that the mean is, which is, you take up all the values and eventually find the one that's the average of that. This median is very, very much something that you can see without doing a calculation. How do you do that? Well, what you do is you order all your data sequentially. So you start with, if we're talking about reviewer turnaround time, you talk about all those that took 0 days, i.e. they took less than 24 hours. Then you put all the ones, then you put all the twos, all the threes, all the fours, and you order the data that way. And you're thinking, I have to do that? No, you don't. Excel does that for you. And so will Origin reports as well. So what you do is, you order the data sequentially from smallest to largest, then the data is divided into 4 equal parts, quartiles. And then the middle 2 boxes contain 50% of all your data points. And so what we're looking at when we report the interquartile range is the distance between here and here, okay? From the end of the first quartile to the end of the third quartile. So 50% of my reviews returned were between whatever these numbers are. So let's say that's 10 days and that's 20 days. So in that scenario, I know here that my median is maybe, I don't know, maybe it's 15, let's say, and I know that 50% of my values were received between 10 and 20 days. Okay. So that's a very simple visualization of the data. This is what I love about interquartile range, is that they are actually very, if you're not into the numbers themselves, visually, it's very easy to understand what it is that we're talking about here. So why does the interquartile range work better than the standard deviation? First of all, it's built off of that sequential ordering, okay? And I'll explain why that makes a difference in a second. I've got a nice visualization for you. It reports the median, middle value for the data set rather than the mean average. This is the number that falls exactly in the middle of all the values that you report once they're sequentially ordered. So that means your outliers do not actually affect anything, okay? Because we're taking is literally the middle value. There's no calculation that will pull you in one direction or another. And if you're still struggling to understand what I mean, here we go. A very simple example. This is that I have a tiny journal of which there were only 12 decisions posted last year. And this is the mean time to initial decision for this tiny journal of mine. So the fastest manuscript received an initial decision in 32 days. The slowest manuscript received a decision in 54 days. My median is 43 days. Okay, that is a middle value that could be calculated here. So right there, that's pretty obvious. The middle number between 42 and 44 is 43. In this example here, I have one manuscript that the wheels just flew off, everything went horribly wrong, and it took 100 days to get that initial decision. And guess what? my median is still 43 days because the middle value between 42 and 44 is 43. Now, I have a slightly different thing that happened at this journal. And instead of the seventh manuscript, if you want to call it that, in the sequence taking 44 days, like it did over here, it took 46 days. And look how that actually affects my median. Now my median goes up. So when we're talking about the consistency of what's happening in the middle of the data set, so I'm not worried about my outliers, I'm not worried about anything like this over here, that actually pulls my median up. So that's why the interquartile range is actually more interesting, because we're talking about, we want to know about consistency of data. And in fact, overall, the consistency was ever so slightly worse because of this. This outlier is just out there. And it's now, if this was the mean average I was calculating, it would have made a right old mess of my mean. But over here, this is what actually impacted most on my median. So how would you report the interquartile range? This is how you would do it in your journal editorial office reports. So you would calculate the interquartile range, and this is the actual equation that you would use in Excel. So you do equals and then quartile.inc. Again, just use the formula builder in Excel to do it. And it would guide you through all the data to select. And essentially, Excel would calculate your third quartile ends at 45 days, and your first quartile ended at 35 days. So the interquartile range is 10 days, okay? So that's right here in the table, okay? So what I'm reporting is, at the end of the day, my interquartile range, IQR, is 10 days. And I would also report what the other quartiles were as well. So my median was 42 days, my Q1 ended at 35 days, my Q3 ended at 45 days. 50% of my values we're in a span of 10 days, which included the median of 42 days. But I'm not saying this is a critical thing. I'm not saying it's plus or minus 10 days of the median of 42. That's how I know how standard deviation works with a mean, but that's not how it works with the interquartile range. What I'm saying is that I have a range of 10 days between the end of Q1 and the end of Q3. And if, like I said, it's a very visual thing. If you've not really seen these before, this is something that we're putting into Origin reports because we love them. They tell you a lot of information. This is a box plot or a box and whisker plot. And so what's going on here? I can tell you right now that this journal had a more inconsistent performance in 2021. This is actually a real example. I generated this for a real live journal, which I'm not going to name. And they had a new editor-in-chief in this year, and the performance has become more inconsistent, which might be expected with a new person on the job. How do I know that? Okay, a couple of things. First of all, this line here in the middle of the box is the median, okay? So I can see, just looking at the median, if I track across, the median has gone upwards. So it took longer in whatever it is that I'm measuring here. Let's say it's days to first decision or something like that. So it's tracked closer to this number 20 here, 20 days. And so my median's gone up. So that's one clue. The second clue is that this box, this red box here, is now bigger than it is 2 years ago. I have very tightly clustered data here. My data was very consistent. We got most of our decisions out in a very narrow band, say between 15 and 18 days. Here, it's now between 16 and maybe 22 days. So I've gone from having a 3-day interquartile range to a 6-day interquartile range. And that is what this box is showing. This is where the end of, this is the end of your Q1, this is the end of your Q3. So 50% of my values are inside this box here, okay? And so the median, my interquartile range, that's the box. My box has got bigger, we're more inconsistent. Okay, what's all this over here? What are these here? These are a plot of your outliers. So in these 2 previous years, my worst manuscript took, what was that, maybe 55 days, 59 days here, okay? Whoa, but what happened here is that I'm now over 90 days. I had a paper that took over 90 days because this line here is plotting the uppermost value, so the worst manuscript, okay? So that's my biggest outlier at that end. Sometimes you see these plots with other dots on them as well, and that just literally indicates on the days here, literally indicates where your other outliers are. But just so you know, the takeaways from this example are, oops, the mean seems to have gone upwards. It's edging closer to 20 days. This box has got wider. That's not good either. It suggests my data is more consistent. And uh-oh, I've got a really bad outlier up here. Now, again, as I just want to stress, unlike the mean, where an outlier can pull it upwards, the median isn't affected by that outlier. So why is the median gone up here? Probably because there's greater inconsistencies in the data. That's why the median's gone up. Nothing to do with the outliers. Okay, finally, why should you care? Well, it's imperative that the correct and most effective techniques, i.e. measures of variance, are applied to interpret meaning of your data, okay? So give this information out with your mean or your median. You're providing context. It'll help people understand what it is that's happening, the behavior underneath the key headline statistic. They can discount, certainly if you're using the interquartile range, the outliers. They're not representative of the typical experience. And what you're trying to convey is, what is the typical experience? An author comes to your journal, what typically can they expect? Consistency is important to speed. So if you want to build policy decisions off of your performance, then run these kind of analyses, run them over time, maybe the last 5, 10 years, whatever, and then look to see how you're doing. And then, institute a policy change, and run the statistic again over the next couple of years and see how that played out. So even if you're not statistically inclined, many of your editors are, and I think they would appreciate these additional statistics. I promise you, it doesn't take you long if you're using Excel to calculate them. It is literally, equals, highlight the data, pick the right formula, use the formula builder, and it calculates it for you. If you use Origin reports, it's literally the button push that allows you to generate the chart, or the table rather, and it's going to be there for you. Okay, so that was my presentation today. I appreciate it might have been a bit stats heavy. I'm not a statistician myself, but I do see the value of these things, and I strongly encourage you to include them in your future reports. Okay, thank you. Bye-bye.
Okay, so thank you everyone for watching Jason's presentation. He certainly gave us a lot to think about in terms of what else is useful to report on beyond averages and medians. So we will open the floor for questions now. We have a small group here today, so I hope you're not going to be shy. Feel free to ask any questions that you may have. Just come off of mute. I see Claire, is that you? Coming off of mute?
Hi, can you hear me okay?
Yep, I can hear you.
Great. So actually my question had to do with reporting an editorial manager to finding the IQR and all that. Do you know if there's standard reports already set up, or would this be a custom report to get those results?
This is Sherry. Hi. I'm not aware of any reports that are standard and already set up in Editorial Manager that report out the median and interquartile range. Usually most of the Editorial Manager reports report out the mean or average.
Right. So would you be able to recommend any custom builds for reports?
Yeah, we could probably look into that. I don't have anything that we already do in that way. Mostly I work with Origin reports, so we pull things out and do them in the app, but we can actually look into that and see if there's an easy way to set that up in a custom report.
Great, thanks.
Thank you, Claire. And actually, I had an editor-in-chief recently who wanted interquartile range, and I'll be honest and say I really had no idea how to do that, and ultimately did pull the data I needed from Editorial Manager and use the formula builder in order to be able to accomplish that.
Yeah, Excel is you can do it pretty easily in Excel. So sometimes the easiest thing to do is to pull your data straight out of Editorial Manager and do it in Excel.
Mm-hmm.
Yeah, I have a editor-in-chief who wants all the standard deviation IQRs, and I've been pulling, actually EM does a fairly good job, setting up all the data to be pulled out to Origin reports in Excel for median. So the standard deviation equation was actually really helpful today.
Excellent. And if you want, I can show you very quickly how to do that in Excel.
Yeah, Sherry, I was going to suggest that perhaps you could show us a little bit of this in Excel and even origin reports if you have the opportunity.
So I have Excel up. I'm just going to make up some data really quickly. We'll pretend it is the time taken for a reviewer to return an individual review. So I'm just going to stick in some numbers. We're not going to do too much. But just to kind of give us an idea, and I will put in one outlier there. So if you're doing the average, we're just going to kind of go through the whole thing. It'll be just for thoroughness. So you can just click on average and then select your range and hit it, and that gives you the average. Okay. If you want to do standard deviation, it's very much the same thing. Maybe this one is the most basic. We'll just do the basic one here. And you can just copy it and it just automatically does it. So how you would read this, I'm going to make these numbers look a little less messy. So you would say that the time for a reviewer to review is 15 days plus or minus 12 days. So that's how we would report that. And that is the standard deviation. For median, same thing. And you can see all of these equations are just already in there. And again, select your, and you'll notice the median comes out a little lower. So it's going to be more in this range. The average is pulled up just a little bit because of our one outlier here, but this is the median. And if you want to do the interquartile range, so Excel doesn't produce IQR. What you do is you calculate the value at the 25 percentile and the 75 percentile and take the difference. So you type in quartile, and you see it right down there. And I'm going to select that and enter. Usually it will pop that up. So if you can see, you get this little help right here, and it asks you what quartile, and then you can just pick, I want the 25 quartile, 25th percent quartile. So we'll enter that. And this is Q1. And then we'll do the exact same thing again. So, and then we'll do the 75th. And if I did the 50th, it would just be the same as the median. Okay, so that's Q4. And then my interquartile range is just the difference of those two. Okay, that didn't turn out. I must have hit something wrong. Hold on. I think I failed to click on something. Let's do. Okay, that's better. And then I'll just take the difference of those two, and that gives you your interquartile range. Do note that you cannot say my median value is 14.5 plus or minus 18.3. You can do that with the standard deviation, the plus or minus notation, because it's based off of the concept that your data is bell-shaped and the data is evenly distributed. The median and the interquartile range are based strictly on numeric order. So there is no guarantee that the median will sit in the middle of your interquartile range. What you can do is report all three of these values to try to give people a fuller understanding of exactly how your data is spread. And then if we want to—
Sherry.
Yes.
Sorry to interrupt you,
Yes.
but can you then explain what what does that mean then, that the interquartile range is 18.3? Can you just kind of explain what that means?
Okay, so that's saying that 50% of your data is within 18 days with a low of 2 days and a high of 20 days, but the spread is 18 days.
Okay.
Is that what you were asking about?
Yeah. Yep.
So that's kind of how we would say it. So that's one thing that Jason mentioned. Also, the standard deviation, that's talking about, I think it's 68% of your data is within the one standard deviation of this value, plus or minus, and the interquartile range is 50% of your data. So 50% of your data is within 18 days. Okay, I'm going to show you real quick in origin reports. So this is origin reports. We have extraction reports set up. So I'm just going to add my data that I've already extracted from editorial manager in this case. So we are building this in. This is coming in the statistics side, but you would just pick what you want. You have your charts down here. This particular table is set up with statistics, so it has it all calculated for you for your data set. So it makes it just really easy and quick to just select it. You can also choose to show it in different ways, like, with the box plot that Jason mentioned before. And you can tell, this is the start of a year. So there's basically no data in that box plot right now, but you can tell that this year you had more outliers, but the interquartile range is roughly the same as it was the year before. So here the interquartile range from 5 days to 15 days. And by year 2020, it was from 6 days to 15 days. So roughly the same. You can also see this line is your median line, and you'll notice it's not directly in the middle of your box plot. So again, the middle point of your data is not necessarily in the dead center of your interquartile range. That's another way that you can do interquartile range, but it's not that hard to pull the data out and do it in either way. Did that help at all? Did that answer any questions for you?
It was very useful. Thank you, Sherry.
Okay.
I did have a question. So, Jason explains why the IQR is more potentially a preferred method of measuring variance versus standard deviation. If we really only have the skills to report standard deviation, is there anything you would advise that we tell our editors about the limitation of that measurement?
Right. So as you saw, it's not harder to calculate the interquartile range, but there are some people that are more familiar with averages and standard deviations. They've heard it more. Maybe they have a science background and the data that they're used to working on is more uniformly distributed, more normally distributed. We call it the bell curve. And so they just feel more comfortable with these statistics. So if they insist on them, report out your average and your standard deviation. Giving them any extra information is always helpful, but you should point out that because our data is not typically normally distributed, that it's skewed data or messy data, however you want to say it, that you're going to have the average is going to be impacted by any outliers. And that it's going to, you may think you're seeing a trend that you're not really seeing because there are one or two really bad outliers. Or maybe you had a bad outlier last year and this year you don't really have that. And so it looks like there's been a more significant change than there is. So you just have to understand that if that's the data they want to go on, that it is more impacted by outliers, and that you might see variations and you might think that there's a change when there may not be a change.
So I will admit that in the journals I've worked on, we've really only reported means and medians, and we haven't done variance spread. So this is new to me to think about. Do you have personal experience with reporting variance spread to your editors in chief? And if so, is it something they requested, or did you suggest it, or how did they react? Was it they were so happy to have this data, or?
So I think people are going to be all over the place. And as you know, as we all know, we all work in journal offices. So if your editors or editor-in-chief have science backgrounds, they're going to be very open and receptive and probably very happy to see this data. It's going to make them feel more comfortable that they understand what's actually going on. If they don't come from a science background, you might find some resistance, or you might find someone saying, I don't need all that extra information. That's just making the tables messy. It's, harder to get through. I don't understand it anyway. But if you can show them, we're all trying to make changes all the time, trying to get things through our journals faster, trying to improve our performance in some way. And if you can, through the use of reporting the variance, show them that they are or are not making an impact, especially if they are making an impact, you will win them over. Because as you saw in Jason's presentation, the mean or median even might be the same year after year, but really that doesn't tell you how consistent you are. And that it's so important for our journals that all the authors get a very similar experience. So if one author, their manuscript just flies through our journal, oh, that's wonderful. And if this other poor person, their manuscript just languishes, then, that's terrible. And you're going to get, inconsistent reputation. So there may be some resistance, but try to report it on something where that there's been a policy change and you're expecting to see some sort of decision. Expecting to see some sort of improvement, and then look at that data, and report the variance on that. And it's in the nuances, and you're really just trying to say with your variance data, we are getting more consistent. All of our authors are getting closer and closer to the same experience.
If you were to find that you do have a wide variance on a particular measurement, what would you suggest is the next step? Do you dig into that to kind of figure out why there's that wide variance, or how would you approach that?
That is definitely a time. That's when you want to start, like you said, digging into it. First and foremost, you want to look at your outliers. You want to, I just want to take just one moment to point out, sometimes this feels overwhelming. People are like, oh, now I have to report variance on everything. Understand that variance isn't reported on all of your data. Mm-hmm. Some data are absolute values. If I said to you, how many submissions did you get last year? You wouldn't say we got between 215 and 230 submissions. No, you got 200 submissions, or you got 230 submissions. There's no variance there. So things like submissions, the number of initial decisions, anytime you say the number of submissions, the number of initial decisions, the number of assignments per editor, these are absolute values, or absolute numbers. You don't need to report variance on those. The other thing that people sometimes get confused about are things we often report out on percent rejection. So they see the decimal. When you calculate that, there's a decimal place, and they think, oh, we must need to report variance. No, this is an actual value. You have a certain number of reject decisions divided by a set number of total decisions. It's a value. When you're going to look at variance, you're talking about timing charts, time to initial decision, because that varies tremendously. One manuscript versus another, time to final decision, time for your editor to assign the first the first reviewer. So you have a number of editors. They have a number of submissions each. So that's going to vary quite a bit. Time for a reviewer to submit their review. This has all this variance in there. So depending on what you're looking at, so let's say it was time for the editor to invite the first reviewer, and that had a large variance in it. Then you would want to break that down by editor and see if some editors were really fast and some were taking a very long time. You would want to maybe look if the editors that are taking longer, did they have one or two papers that were taking longer? So you want to dig in and try to find, in that case, you would want to look, is it a certain type of manuscript that's harder to get the reviewers in place? So you just need to dig in, but you just have to it's sort of like an onion. You just have to keep peeling back the layers until you can find the source of where the higher values are coming from.
Thank you. It's really helpful. Are there any other questions before we close out the webinar? Well, I hope you all found it to be useful. This reminds me of my stats class in college that I ran from screaming, but you did a great job, Sherry, of making it understandable, as did Jason. And I see the value of presenting this information for our journals. So thank you so much. I'll just remind you that a link is going to go out in a couple days with the recording to this webinar, and you're welcome to share it with any of your colleagues. And be sure to follow Origin Reports on LinkedIn and on Twitter. Thank you very much, everyone. Have a good rest of your day.